Hello, I welcome you all. The problem reads, the basketball passed through the hoop even though it barely cleared the hands of the player B who attempted to block it. Neglecting the size of the ball, determine the magnitude VA of its initial velocity and the height h of the ball when it passes over player B. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. Let's remind ourselves of the basic equations. Three basic kinematic equations. We have velocity, which is the time derivative of position. We have acceleration, time derivative of velocity. Okay. Then from the two equations making dt subject to a formula, we have this derived equation. From the three, we are able to derive a number of different equations depending on the boundary conditions. One of the most common one is when acceleration is constant at t equal to 0. We have s naught and v naught, and from this we derive s naught. S is equal to s naught plus v naught t plus half ac t squared. V is equal to V naught plus ACT, and V squared is equal to V naught squared plus 2AC S minus S naught. Alright, so what do we have here? Of course, we do have horizontal and vertical motion that we need to separate and then use those equations to solve for the unknowns. We want to find VA, later on find H. So let's start with the horizontal motion. We start with the horizontal motion. Let's write down the components. So here we do have a vertical component. A horizontal component is constant throughout. Of course, here we have the final velocity there, which will have also some components. We have the vertical one and we do have the horizontal one, which is constant. So this one is VC, and then we have VCX, which is equal to VAX. Then this is VCY, and then we have this angle here, which is theta C. Okay. Then here we do have VAY, which is equal to VA sine 30. And this is VAX, which is equal to VA cos 30. Right. What do we have here? Of course, we want to use this equation for now. We are using this one. So we have S equal to S naught plus V naught T plus half AC T squared. So we have S is equal to 30 feet. Okay. S naught is equal to 0. V naught is equal to VAX, which is just equal to VA cos 30. And then we have AC, since VAX is constant, this is equal to 0. So what do we have here? We are going to have 30 is equal to VA cos 30 okay, times t. Right. I'll make VA here as subject to the formula. So I'll say this is equal to 30 divided by t cos 30. Let's go to the vertical motion. We go to the vertical motion. Under this vertical motion, we are dealing with feet. So we need to convert the acceleration due to gravity into feet per second. So we have 9.81 meters per second squared. Let's convert this. 1 foot is equal to 0.3048 meters. Meter and meter cancels. This gives us 32.19 feet per second square. So our AC is just equal to minus 32.19 feet per second square. Alright, we just create a boundary. I create a boundary like so. Okay, something like so. Right, there we go. So we are using the same equation. S is equal to S naught plus V naught T plus half AC T squared. Our S in our case is equal to 10. Our S naught is equal to 7. Our AC is equal to minus 32.19. Right. And then we have our V naught, which is equal to VAY, and this is equal to VA sine 30. Therefore, this becomes a 10 equal to 7 plus VA sine 30 times T minus half 32.19 T squared. Alright. What do we do? I'll replace this VA here. Okay, this VA, I'll replace it here. Right. So feeding VA into there and writing this, we'll have a 16.095 T squared equal to minus 3. Okay, we take the 10 the other side. You take this the other side. So minus 3 plus 30 T cos 30 sine 30 T. This and this goes. Therefore, T is just going to be equal to plus or minus 3 plus 30 by 0.5, which is 15 divided by cos 30, then divided by 16.095, then square root. So we have the time plus or minus 9.433 seconds. So this is the time. Let me check it again. Minus 3 plus 30, which is a 15, divided by cos 30, divided by 16.95, square root of that. We have 0.9433. Alright, this is the time it takes for the ball to move from A to C. Okay, so I'll say time of flight from A to C, T is equal to 0.9433 seconds. Of course, that is not the question, but I just wanted to show that as well. So let's find VA, so we can use this equation. So VA is just going to be equal to, VA is equal to 30 divided by T cos 30, and we know that our T is equal to 0.9433. Therefore, our VA is just equal to, that's 30 divided by 0.9433 times cos 30. Okay, so this gives us a 36.72 feet per second. So 0.9433 times cos 30, then we have 30 divided by answer 36.72. Alright, what else do we need? We want H. So for us to find H, we have VA. We can use which equation? Okay, so we can use this equation here. We need the time that it takes from A to B. Okay, and again, using S is equal to S naught plus V naught T plus half AC T squared to find H. Let's start to find H. Let's start with horizontal motion. So say for horizontal motion, we already talked about what we have. Of course, in this case, we have S equal to H. We have S naught. Sorry, we are talking of horizontal. S is equal to 25. We have S naught equal to 0. And then we have V, of course, which is just VAX, which is equal to 36.72 cos 30. Of course, AC is equal to 0. Therefore, this just gives us a 25 equal to 36.72 cos 30. Okay, times T. So therefore, our T, making T subject to a formula here, this just gives us plus 36, that is 25 divided by 36.72 cos 30. This gives us a 0.7862 seconds. So this is how much time it takes for the ball to move from A to B. Okay, so time of flight from A to B. Well, okay, it is T equal to 0.7862 seconds. So with this in mind, we can now use the vertical motion. Okay, for the vertical motion, we are using the same equation. So we have S equal to S naught plus V naught plus half AC T squared. So we have everything. S is equal to H, S naught is equal to 7, SC is equal to minus 32.19, and we already have V naught is equal to VAY, which is just equal to 36.72 sine 30, and we have T is equal to 0.7862. Therefore, from this equation, you can simply say our H is just going to be equal to S naught, which is 7, plus V naught, which is 36.72 sine 30, and then we are multiplying this by the time, which is 0.7862, right? That is 0.7862 minus 32 minus half 32.19 by the time, which is 0.7862 squared. Therefore, H is just going to be equal to 7 plus 36.72 sine 30 times 0.7862, okay, minus 0.5 by 32.19 by 0.7862 squared. H therefore is equal to 11.49. H is equal to 11.49 feet. So 7 plus 36.72 sine 30 times 0.7862 minus 0.5 by 32.19 by 0.7862 squared, 11.49. I think you will not find the angle theta C. You can check out these ones yourself. I think we are done with this particular problem. Of course, we found the time of flight. It was not part and parcel of the problem. See the time of flight from A to C. We also found VA. Okay. And then we also found this and the height. Okay. And then we also found time of flight from A to C, A to B. Okay. Then we found H. Alright, we didn't find the final velocity at C, didn't find the angle, ran out of space. We can do those things later on. Moreover, they were not part and parcel of the problem. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye. I'll see you in my next screencast.